Hello, this is Dr. Flight. Hope you're doing great today. We've got a fantastic topic to talk about, and this would be comparative scaling techniques. And so what we're going to do is basically run through a number of different ways we can create questions or scales and the different names and types of scales that those are. So buckle in, obviously, pause the video if you need to at times, and we'll go from there. Now, there'll be a companion video that talks about non-comparative scale methods, but comparative scale methods basically involve this idea that you want to you have two items that the respondent is considering, and they have to compare their feelings or their ideas about them to each other. They might also be ranking them or making some type of comparative evaluation. Non-comparative scales are simply scales that don't require comparison to take place. The scales are independent of other stimuli. So in this case, we're going to look through some examples of comparative scales where you have, again, objects that are being compared and then evaluated in context to each other or ranked in some type of way to each other as well. Okay, so if you look at the different variety of different scaling techniques, these are comparative scales. And so we'll talk just a little bit about each one of these: paired comparisons, rank orders, constant sums, and then Q-sorts. Some of these are used a lot. Some of these are used less. They are all used in market research, however, so it's a good idea to kind of be familiar with all of these different methods. Okay, so paired comparisons. So this is the most common type of comparison that you might have, or comparison scale that you might have, but you are presenting two objects or two elements or stimuli to a respondent, and they're asked to rate them compared to each other. The data that we get will be ordinal in nature. And one very widely used method where you make comparisons is something called a max diff, or maximum differential or difference scale. It's similar to a Q-score, which you see later, but basically the idea is you give respondents in a max diff test, you give respondents an option of like maybe a product with one attribute and then another product with a different attribute, and you just simply ask them to rate them or compare them, and you put things in order and some things like that. Okay, but max diff is one example here, and we'll see some of these a little bit later on as well. Okay, so preference ranking, though. Here's an example of using preferences with comparisons. Here, the instructions would be for the respondent to pair 10 different shampoo brands. Put in pairs. For each pair, indicate which two brands you like the best. So in other words, the respondent is going to see, in this case, like Germac and Finesse, and they will look at these two and be asked, which of those two, Germac or Finesse, do you prefer? And in this case, the way you read this box, the Germac Finesse, there's a 1 in that indicator there. It means that the brand in the column was preferred over the brand in the row. So in other words, Germac and Finesse, this respondent preferred Germac to Finesse. They preferred Vidal Sassoon or they provide Germac to Vidal Sassoon, but they preferred Head & Shoulders over Germac because it's a 0 there. Okay, so you can kind of look through this entire chart, right? And you can see when one was compared to the other, what that was, and you'll kind of make some assessments here. You can just kind of look and see, well, look, that the Head & Shoulders, if you look at the column of Head & Shoulders, they have 1s all the way down. So that's probably the most preferred product here. The last least preferred looks like Vidal Sassoon. They have no ones at all, right? So we can assess this data, kind of seeing what's preferred and what isn't. So Head and Shoulders would appear to be the most preferred, whereas Germac comes in second, Finesse third, and then Vidal Sassoon, or Pert, I guess, fourth, and then Vidal Sassoon would be fifth. Okay, so this is like a rank ordering, but it's a comparison, right, between two preferences, two objects that would be preferred. So this is a comparison, a paired preference or ranked preference indicator. Right, it's pretty simple to do, pretty straightforward. The data, again, that's revealed is going to be ordered. So we have an ordinal data, and this is what it is. Now, there is some research you could do where you look at the distance between the different scores, and so you could maybe create or make this into a you can think of it maybe as interval data, but it's really ordinal data, and that's the way you should think about it, treat it. Okay, rank order, same type of idea. So rank order is if you're given, instead of a paired comparison, now you're going to be given all the objects together and put them in order. So that'll be the goal. Now, again, we're just saying one is better than the other. We're not saying it's better by how much. So if you order a list of items 1, 2, 3, 4, 5, 1 is being your favorite, 2 is being your next favorite, and so forth, we know 1 is better than 2, but we don't know by how much. So that again suggests that this is ordinal data that we'll be using here. Okay, so rank the various brands of toothpaste in order from 1 to however many there are, so you can move them around. You can, depending on how the survey software you have, you can have people put the numbers in to rank order them, or again, kind of move them around. Okay, just as a research note, this is actually true in a lot of cases. We often randomize the order by respondent so that there's not an order effect. FYI, that's one thing that we want to do when we do this. Okay, number 3, another type is a constant sum comparative scale. In constant sums, what we want to do is we want to give the respondents a total number of points, if you will, and then let them distribute the points across the different options that are provided. Okay, so in this case, the attribute I mentioned, maybe if you are offering a product and you have 7 or 8 different features to the product and you ask them to distribute 100 points across the 7 or 8 attributes, with the most important getting the most, least important getting the least. And 0 can count too. But the column, however many they assign each attribute, whatever the sum is, has to sum up to the total number that you were allowed. Now, in this case, we do have an idea of distance between responses, because we have this new number. If one gets a 50 and one gets a 25 out of the number of points that are assigned, the 50 is theoretically twice as important as the feature that got the 25. So here we can do a little bit more interpretation, but at the end of the day, all the points have to add up to the correct amount, and we can do a distribution and kind of go from there as far as how this looks and what this, how this makes sense. Okay, so suppose you're to make 10 purchases in the future from these following celebrities. Specify how many purchases you would make from each one of these celebrity brands. Okay, so here you have 10 points or 10 purchases, and you can distribute them all. So this is a constant sum. So whatever we come up with, however many people respond to, it has to equal the 10. Now, in this case, we can do some, as I mentioned, do some other things with the data itself. And we collected data from over 1,200 respondents, and the number that was chosen or applied, the number of purchases that were applied for each of the brands is reflected here. So there's a count for each. So there's a number of purchases, and then we have a percentage. So out of the respondents, if each respondent had 10 purchases, Kate Hudson would get 15.4% of all of those purchases. You might even extend this to suggest this might be a market share, since it's a percentage of the total that Hudson would have and all the others as well. Yeah, so we don't necessarily know in this case the trade-offs, like if Hudson has taken market share from others and such, but we could do some fun analysis, and this is actually very insightful, this type of a constant sum scale. All right, and we would typically, again, treat this like ordinal type data. The last is called a Q-sort, and again, there's only 4 of these that we'll look at in this video, and these are comparisons, which again, all research does this quite a bit, but a Q-sort is one where you have multiple attributes happening simultaneously. So the paired comparisons where you're looking at 2 things at once. This would be if you had multiple criteria you were looking at simultaneously. So sometimes we call this conjoint analysis. And one of the applications here is where you create products and each product is viewed, and then the respondents put these products in order. If we have enough respondents do this, we can determine how important each attribute is, but also if each attribute has different levels, then we can measure that as well, and we can turn all of this into data. And in conjoint analysis, we actually measure what's called the part worth utility of each criteria, of each attribute, and each level of each attribute, which is kind of a cool thing. So let's just a quick example of a Q-sort with a conjoint analysis application is, let's say we have a salsa product, and there are 3 different attributes, and each has different levels. So one attribute is density. So we have regular, thick, and extra thick salsa. That's one attribute with 3 levels. We have spiciness. We have medium, medium hot, and extra hot. So we, again, second attribute, 3 levels. And then color. We have red or green. Now, we have 2 attributes here. Now, if we multiplied the levels together, we would get a total number of possible products we could possibly have if we intermixed all of these attributes. So we have 3 density times 3 spicy times 2 color, which gives us 18 total possible products. So the respondent's job then is to look at a description of 18 different products and then put in order their preference. And then from this, we can again, we do this with a lot of respondents, and then what we can actually do is we can understand exactly how important each of the 3 levels or each of the 3 attributes are, and how much preferred each level is in each attribute. So this is happening kind of in a couple different dimensions, right? A couple different ways, right? So so we have 18 different product categories. We have the regular, thickness, thickness, and extra thick. Then we have our 3 spiciness levels, and then we have the color. We have 18 different product cards or qualities or features. And then we have the order of the most preferred. So the most preferred, number 1 out of all of these, is the thick, mild green. The least preferred is extra thick, extra hot green. So, that's kind of it. Now, again, if we dig into the data a bit more, we'll actually get a measure of how important thickness and spiciness and color is, and we'll get the preferred level of each of those three. So this type of approach, this type of way to collect data, again, it's part of a statistical technique called conjoint analysis. It's also a max diff, I mentioned that earlier, is another version of this. It's a little bit different, not done quite the same way, but it's a preferencing where we compare objects and then we rank order them. Okay, so this video hasn't been a long video, but it describes this idea of these comparative scale techniques that we use, especially in market research when we are looking for the respondent to give impressions of choice, oftentimes, when multiple choice selectors are available. All right, so let me know if you have any questions. And thanks for listening.